Good morning, students. Now we'll continue area of integration. Sketch the region sketch the region lying in the first point and bounded by y equal to x square, x is equal to 0 and y equal to 1 and y equal to 4. Find the area of region using integration. Now first you have to find the bounded regions. Okay. Set the graph of the region lying in first quadrant and bounded by y equal to 9x square. Okay. X is equal to 0, x is equal to 0 and y equal to 1, y is equal to 4. First y is equal to 1, y is equal to 4 you have to set. Y is equal to 1, this one, 0, 1, y is equal to 4, this one. Right? Between these two. So given curve is x square is equal to 1 by 9y, so x square is equal to 1 by 3 root y, x is equal, right. For ay. So x square equal to 4ay means it will be in the upward curve. X is equal to 1 by root 3 root y. So this is the curve. You will be getting. Okay, now y equal to x square. This is the 0. So named as A, B, C because this is the bounded region in between. Between x is y equal to 1, y equal to 4, x is equal to 0. Right? X is equal to 0 means this one. And find the region using integration. First quadrant. Okay? So the area of from the figure, the area of the region is equal to A, B, C, D, A. Okay. Now, you have to find this area. Okay. So this is y is equal to 1 and this is y is equal to 4. It is a parabolic curve open upwards and is symmetric about y-axis and pass through origin. It is a parabolic symmetric to y-axis and passes through origin. Now, 1 to 4 x is y vertex. So A is equal to area is equal to integral 1 to 4 x dy. X means what comes here? That is equal to integral 1 to 4 X means 1 by root 3, 1 by 3 root y dy, which is equal to 1 by 3 into y power 3 by 2, 1 to 4 into 2 by 3. That is equal to 2 by 9 into 4 power 3 by 2 minus 1 power 3 by 2. That is equal to 2 by 9 into 8 minus 1. 14 by 9 square units. Like this you will get. Are you clear? This way you will be getting 14 by 9 square units you will get. How? What is the question you see? Sketch the region lying in first quadrant. Okay? This is the first quadrant. Okay? And bounded by y is equal to 1 and y is equal to 4. Right? And x is equal to 0. X is equal to 0 means this is x is equal to 0. Right? So in the parallel to x axis, parallel to y axis, and in the first quadrant, so area is curve given, and according to this is the parabola, upward parabola. Then you got the value of x in terms of that. You got the region A, B, C, D, A. Now it is symmetric to y axis, so you have to take x dy. So this is dy, and this is x. Okay. Now x dy means you have to take y limits 1 to 4. X is equal to 1 by 3 root y, that was taken, and 1 to 4 limits are taken, and then substituted, you will get the area. It is only one side because in the first quadrant, so no need to multiply with any number or as a symmetric constant. So you can leave like this value as 14 by 9 square units. Are you clear? So this way you get the area. So most of the cases we will be getting the curves symmetric to x-axis. But in a specific cases, we may get the area of to be bounded by the curve can be with respect to y-axis also. Are you clear? So in this case, this is the compulsory curve which you can have to do only with y-axis because it's symmetric to y-axis only. You cannot take with x-axis. It will be difficult to solve also. So take in the way x dy. So 90% you will get y dx, but 10% you may get x dy also. Okay, clear? But you need to renovate the curves and then given lines properly to find the bounded region. So you must be very well knowledge with the type of the equations as well as their forms, conics and all the circles, straight lines, everything, parabola, ellipse, hyperbola, and then curves also, circles, ellipse, and all this. Okay, so standard forms of lines with respect to axis also you should be very much clear. Then you will be able to get the bounded region, enclosed region very much clearly. So I think you are clear. So next part will go, note it down. This is bounded region. Next question. Find area of the smaller part of the circle. X square plus y square is equal to a square. Cut off by the line x is equal to a by root 2. So circle you have to take and the line is cutting the circle. So you have to draw the figure carefully in this part. Okay, find the area of a smaller part of circle. So what is cut out part? In that smaller part you have to take because the line cuts the circle into two parts. One is bigger, one is smaller. So smaller part area you have to find. That figure you need to do. So all this area of the figure or integration will be starting with respect to the figure only. So 0, 0, a 0 because this is the radius. Now this is the line x is equal to a by root 2 because parallel to axis. Now this is the intersection point of the line and the curve. Okay, so we'll see this part. So here you take as A, B, C. Okay, from the figure, the point B is the intersection point of circle x square plus y square is equal to a square and x is equal to a by root 2 line. Therefore, a by root 2 whole square plus y square is equal to a square implies y square is equal to a square minus a square by 2, which is equal to a square by 2. Y is equal to a by root 2. Since x comma y is in Q1, y is equal to a by plus a by root 2. Now, therefore, b is equal to a by root 2 comma a by root 2. B is equal to, what about C? Since C is the foot of the perpendicular for B, therefore C is equal to a by root 2 comma 0. So this point a by root 2 comma 0 will come. Now this part is the, okay, this is the small part of the area. So you name this as D. Okay. So A, B, C, D, A, B, C, D, D, A, B, C, D. Okay. Therefore, area bounded by the circle and curve and the line is D, A, B, C, D. Is divided into parts, symmetric parts. CABC A1 and CDAC A2. Okay. Therefore, A is equal to A1 plus A2, which is equal to 2A1, 2 into integral. See, this area is covered by line circle only. Okay, integral A by root 2 to A. Because the x limits only you have taken y dx you have taken. Y means what comes covered by the curve. So root of a square minus x square dx. Because you are asking the smaller part. So 2 times you have to do. This is a by root 2 to a. This is covered and closed. So root of a square minus x square dx. 2 into. Okay, now you have to find this area now. Therefore, A is equal to x into root of a square minus x square by 2 plus a square by 2 into sine inverse x by a by root 2 to a. That is equal to now this part you have to simplify. 2 into so a by root 2 into a by 2 root 2 into a square minus a by root 2 means a square by 2 root of a square by 2 means a by root 2 plus a square by 2 into sine inverse 1 by root 2 minus a square by 2 into sine inverse 1, because this part will be 0, right? That is equal to, is it visible? 2 into a square by 4 plus a square by 2 into pi by 4 minus a square by 2 into pi by 2. So a square by 2 into pi by 2, 2 into a square by 4 minus a square by 2 into pi by 2, pi by 8. That is equal to 2 by 8 into 2a square minus pi a square, 1 by 4 a square into 5 minus 2. A square by 4 into 2 minus pi square units. This is what. So this way you would get two parts you have taken, both parts are same. This is because one is negative, one is positive. So we have taken neutral only because this is modulus only for both the cases. Okay. Okay, right now, next question. So two parts, this is a smaller part, this is a, suppose you ask a bigger part, so you have to take this to this, and again into 2. Again, this to this means bounded by what? Curve only. Again, this part only you have to take. Into 2 parts you will get. Okay, bigger part mostly you will not ask, smaller part only will ask, but smaller part is 2 parts again, into 2 you have taken. Next, we'll do one more question. Find the area bounded between the curve y square to 4x, line x plus y is equal to 3, and y axis. y square equal to 4x. So automatically it's a parabola. X plus y is equal to 3. So x plus y is equal to 3 means this will come like this. It should go through 1, 2, 3. This is y square is equal to 4x. This is x plus y is equal to 3. Now see the question, find a point between the curve y square 4x, y x plus y 3 and y axis. And y axis means this is the bounded region he is asking. So name this as O, A, B, O. Okay, now clear? This is 2, 1, 2, 3. Now what is this part, this line, this is, this point you have to see. Okay, then again this point also you have to find. If you know this point, that is enough. Okay, so up to here, how will you find this area? So first to draw a line this way. Okay. From here to here, this is the line, and from here to here, this is the curve. You have to take like this. M you have to take. Okay, then from the figure, right? B is the point cut out by line with x-axis, with the y-axis, comma A is the intersection point of line x plus y is equal to 3 and y curve y square is equal to 4x, y square is equal to x, comma M is the foot of the perpendicular for A. Now y square is equal to 4x, x minus 3 whole square is equal to 4x. So x square plus 9 minus 6x is equal to 4x. X square minus 10x plus 9 is equal to 0. X is equal to 9 or 1. Then y is equal to 2 or minus 6. But y minus 6 not possible since y cannot be negative. Therefore, x is equal to 1 comma 2 is the point. Therefore, A is 1 comma 2. Right? This is x1, y2. x1, y2. Therefore, M is equal to, since A is x1 comma 2, M is equal to, what comes here? Actually 0, 0, 2. Okay. What about B? B intersects y-axis. So actually is 0. Okay. So what comes y 0, 3? B is equal to 0, 3 since B intersects y-axis. Now you can find the required area of the region, bounded region is equal to OABMO. Okay, that is equal to A. Therefore, A is equal to area of OAMO A1 plus area of MABM A2. So MABM is with respect to line and OAMO is with respect to curve. Okay. So therefore, that is equal to, that implies A1 is equal to integral. This is 0, comma 2, right? This is 0, 0. 0 to 2. You take x dy. X means with respect to curve. X means 1 by 2 y. That is equal to half y square by 2. Y square by 4, na? Y square by 4. So y cube by 3. One by 2. 1 by 4 into 8 by 3 minus 1. 1 by 4 into 5 by 3, which is equal to 5 by 12 square units. Similarly, A2 is equal to again 52, 2 to 3 x dy. X dy means x is equal to 3 minus y dy. That is equal to 3y minus y square by 2. Nine minus 9 by 2 minus of 9 by 2 minus 4 by 2. This is equal to 9 by 2 minus 5 by 2, which is equal to 2 square units. Nine minus 9 by 2. 9 minus 9 by 2 minus of 4. Oh, 2 का बेटा नहीं calculation का. I will take this wrong. This is wrong. Here 1 by 3 na. So 7 by 3. 7 by 12. Right? Now 9 minus 9 by 2 minus of 6 minus 2. So 9 by 2 minus 4, which is equal to 1 by 2 square units. Therefore, A is equal to A1 plus A2, which is equal to 7 by 12 plus 1 by 2, so that is equal to 13 by 12 square meters. That is answer. Okay, like this, see, you have taken the form, then it is, this area is enclosed by this line and this curve. So you have taken the point with respect to y means, so x dy, you have taken with respect to x dy by axis. Okay, two areas are found and A is the, so area of the bounded region is equal to 13 by 12 square units. So clear? Okay, note down. All the thing is depends upon this figure, what you are taking. Figure is proper with respect to intersection of points and vertices, then automatically bounded region will be clearly known. It is supper because you should have a bounded part. Bounded part is respectively with respect to the given thing only, either by line or by curve. Okay, clear? Note down. Okay, now we'll continue. One more question. Using integration, find area of the region. Automatically it is meant only. Integration means find the area of the region in the first quadrant enclosed by x-axis, line y is equal to x, line y is equal to x, and the circle x plus y is equal to 18. So the question, first you have to plot the figure. Okay, clear? Our circle x square plus y square is equal to 18. First quadrant include x-axis, line y is equal to x. Y is equal to x means this is the line. X square plus y square is equal to 18 means there is a circle. Three root 2, comma 0. This is x square plus y square is equal to 18. First quadrant enclosed by x-axis, line y is equal to x. So this is y, y dash, x, x dash. Enclosed by x-axis, line y equal to x circle. So this is the region you will get. X-axis. So this is the point. This is O, this is A, and this is B, O. From the figure, B is the intersection point of circle x square plus y square is equal to 18 and line y is equal to x. Now you see this point and M. Now you can see here the bounded region is OABO as A. A is equal to area of OMBO A1 plus area of MABM A2. MABM, right? So 2x square is equal to 18 implies x square is equal to 9 implies x is equal to 3. X is equal to 3 means y is also, therefore y is also 3. So B is 3 comma 3. Therefore M is equal to 3 comma 0. This is 3 comma 0. Therefore A1 is equal to area of OMBO is equal to between 0 to 3 y dx. Y means line, y is equal to x means this is the line y is equal to x now. Okay, so y dx means y means x dx. X square by 2, 0 to 3, 9 by 2, minus 0 which is equal to 9 by 2 square units. Next, A2 is equal to integral 3 to 3 root 2, this area, and this is by curve. So what comes root of 18 minus x square dx, which is equal to 3 to 3 root 2 root over 3 root 2 whole square minus x square dx. This is our formula, x into root of a square minus square by 2. So x into root of 18 minus x square by 2 plus a square by 2 means 18 by 2 into sine inverse x by a. X by a means x by 3 root 2. 3 to 3 root 2. Now that is equal to 3 root 2 into this value is 0, 18 by 2, 9 sin inverse 1 minus 3 by 2 into root 9 into 3, okay, minus 9 sin inverse 1 by root 2. 9 into pi by 2 minus 9 by 2 minus 9 into pi by 4. Now 9 pi by 4 minus 9 by 2. Therefore, what is the total area? A is equal to A1 plus A2, which is equal to 9 pi by 4 minus 9 by 2 plus 9 by 2, which is equal to 9 pi by 4 square units. Like this you will get answer. So clear? So these are the most expert cases because it will be into two parts, line and curve like that. Okay? See, once you have understood the question, you framed it into figure, you are able to found the bounded region, and then identify the respective limits by intersection, and then taking the parts added, that will come. Integration is nothing only here. There won't be a tough task for integration, but finding the bounded region is should be very much attentive in understanding the question and then plotting the feasible region. That is very, very important. Okay, next. Next, we'll go to the next part. Area between the two curves. Okay. Area enclosed between two curves. Again, it is same only. There is no much difference. area between two curves in an interval. Suppose when f of x greater than or equal to g of x, case 1 in AB. So this is the curve, and this is this. This is A, and this is B. So this is f of x, this is g of x. This is the region. So you can take this is the way. When suppose f of x is greater than g of x, okay, in A comma B, then we take a vertical strip whose width is dx. And length is f of x minus g of x. Because this is a difference of f of x minus g of x and width is dx, right? Then area is equal to automatically this area will come. Then area is equal to integral a to b f of x minus g of x dx. That is equal to integral a to b f of x dx minus integral a to b g of x dx. Next is case 2. When f of x greater than or equal to g of x in a to b, a to c, and g of x greater than or equal to f of x in c to b. Suppose the curve is like this. So y is equal to f of x. This is g of x. So in this case, you take a strip f of x minus g of x, and in this case, you take a strip g of x minus f of x. So this is A, this is C, and this is B. Here y is equal to f of x. Right. X is equal to A, x is equal to B. This is y dash x dash. Suppose f of x greater than or equal to g of x in a comma b, therefore We take two vertical lines as f of x minus g of x in A to C and g of x minus f of x in C to B. Therefore, A is equal to A1 plus A2, which is equal to A to C f of x minus g of x dx plus C to B g of x minus f of x dx. Like this, you will get two areas. This is A1 and this is A2. Here f of x is upper, so A1 will come, g of x will come, here g of x will come. Here f of x upper, g of x lower. Here g of x upper, f of x lower, like that. So like this cases will come according to the curves. So we need to adopt the system and identify the bounded regions. That is very crucial part. Then automatically finding the limits, then applying, then integration is a very formal sake. Okay. So note on this part. Once we are clear, we'll go for other cases also, with respect to axis also, and other cases also. Okay, noted? Let's start case we'll see here. By two curves and axis, area bounded by two curves and axis. The area bounded by y is equal to f of x, y is equal to g of x and x-axis is a is equal to a1 plus a2, which is equal to integral a to c f of x dx plus integral c to b g of x dx. where C is the intersection point of y is equal to f of x and y is equal to g of x. Next. Another case is there. We'll get here. This is y is equal to C, y is equal to B. With respect to y-axis, x is equal to g of y, f of y, x is equal to g of y. Note, area bounded by the curves x is equal to f of y, x is equal to g of y in lines in symmetric to y-axis. Zero less than equal to f of 0 of y less than equal to f of y for all y belongs to C comma D, and between the ordinates y is equal to C comma y is equal to D is a is equal to integral C to D f of y minus g of y dy. You got 0 to this part, you'll get, and this is the area you have to find. Right, now all the cases we have seen, now we'll find between the two curse cases from tomorrow. Thank you.